this tutorial, I'm going to help you understand the differences between constant velocity and constant acceleration. To do that, I have a car and I have a track. I'm going to do a demo, and I'm going to convert the demo to a graph, a displacement versus time graph. We're going to use the math to convert it to velocity versus time graph and acceleration versus time graph. So let's get started. The car starts straight from 0 meter, 0 second, right? First 2 second, right? It moves only 1 meter with constant velocity. That was a constant velocity. Moved only 1 meter, past 2 seconds. Next 2 seconds, from 2 seconds to 4 seconds, the car is at rest. So the change in displacement is 0, the velocity is 0, acceleration is 0. Next 2 seconds, from 4 seconds to 6 seconds, the car is speed up, covers only 4 meters. So covers only 4 meters. So what you are looking for is the car is speeding up. So it's gonna stop at 5. Never stops, but the only reason I stop to show the next segment. And next segment is from 6 seconds to 8 seconds. The 6 second to 8 second, the car moves with constant acceleration. But look what happened. It covers only 4 meters, but looks what happened. It slowed down to 0. Why did it slow down to 0? That's what you want to discover, right? I said constant acceleration. How did it slow down to 0? Because the velocity and acceleration was at the opposite direction. Now it reverses the direction, right? The car reverses the direction. So now we are at 9 meters, right? It reverses the direction. How much did we spend? 8 seconds. From 8 seconds to 10 seconds, the car is speed up. Why the car is speed up? Because velocity and acceleration are the same direction. So it's speeding up to go back to 5 meters. Okay. So why did I stop? I stopped to show the next segment. What is the next segment? The next segment is segment E. Segment E, the car moves from 10 seconds to 35 over 3 seconds, right? With constant velocity, constant negative velocity, okay, with 0 acceleration, and it's stuff at origin. Okay, now let's see whether we can graph it. What is going on over here? The car moves 2 seconds with constant velocity, covers only the distance of 1 meter, right? And then next 2 seconds, the car, next 2 seconds, the car is at rest because the change of displacement is 0. Next 2 seconds, the car is speeding up. Next 2 seconds, the car is moving with constant velocity. And finally, the car moves with constant velocity and is stopped at the origin. This one is 10 and this one is 35 over 3. So this is what you saw. So our goal is to explain the graph now. Over here, the velocity vector is positive. Over here, velocity is 0. Velocity is 0. Over here, the velocity is positive. Over here, the velocity is also positive. Over there, the velocity is negative. Over there, the velocity is negative. Okay, now let's see acceleration. Acceleration is 0 here. Acceleration is 0 here. Acceleration is positive here. Acceleration is negative there. Acceleration is negative here. Acceleration is negative over there. And acceleration is 0 over there. Okay. So when acceleration is 0 and velocity is positive, we call it constant velocity. This one, we call it, when velocity is 0, acceleration is 0, you can call it constant displacement. When velocity and acceleration are at the same direction, you're going to call it object is speeding up. Why? Because velocity and acceleration vector same direction. When velocity and acceleration are at the opposite direction, object slowing down. Why is that? Because velocity is positive, acceleration is negative. Slowing down because velocity and acceleration at opposite direction. Over here, the object is speeding up because speeding up. Over here is the same thing, constant velocity, constant negative velocity, constant negative velocity. When acceleration is 0, is either constant positive or constant negative velocity. In this case, this is constant negative velocity. In this case, this is constant positive velocity. Okay, very good. Now, the next thing we're going to do, we're going to write the equation, this one. So we have 0, 0 and 2, 1. All right, so what do you know about slope? Slope is y2 minus y1, x2 minus x1. y2 minus y1. y2 is 1, 1 minus 0 is 1, and 2 minus 0 is 2. All right, so slope is 1 over 2, and slope is velocity. So velocity is 1 over 2. So, and as you see, the y-intercept is 0. So y equal to mx plus b. mb is 0. So y is equal to, since this is slope, this is velocity, half x. So p of t is 1 over 2t. So this is just 1 over 2t. This is just 1, right? P of t is just 1. So this is, I showed you before, P of t is just 1. Because this is, the displacement is constant. Change in displacement is 0. The next one, from here to here. So this is, you have 4, 1. And then 4, 1 is vertex. This is a vertex. What is vertex? Vertex is where object changes, reverses the direction. That's the definition of vertex. Okay, what is this one? 6, 5. 6, 5. All right. So let's do the math. So y equal to ax squared plus bx plus c. Y equal to ax squared plus bx plus c. And x is equal to negative b over 2a. This is the vertex formula. So what is the vertex? X is 4. equal to negative b over 2a. Okay, so b is equal to negative 8a. All right, so now let's do this point. So y, let's see, you have y is 1, x is 4, so 16a plus 4b plus c, y is 5 and x is 6, so 36a plus 6b plus c. So if you do the math, then what do you get? You have 36a, let's do it over here, 36a plus 6b plus c is equal to 5, and 16a plus 4b plus c is equal to 1. So you can negative negative cancel. You have 20a, you have plus 2b is equal to 4, right? Okay, so what is b? B is negative 8a, so 20a minus 16a is equal to 4, so 4a is equal to 4, so 4a is equal to 4, so a is equal to 1. Okay, so we know a is equal to 1. Okay, that means we know b. What is b? B is equal to negative 8. Then we know c. What is c is equal to? All right, let's find it out. So 1 is equal to 16, a is equal to 1, and b is equal to negative 8. So you have 1 is equal to negative 16 plus c. So c is equal to 17. So c is equal to 17. So y equal to ax squared plus bx plus c. So y is equal to a is 1. So x squared plus minus 8x plus 17. So p of t is equal to t squared minus 8t plus 17. So we finally found this one. P of t is equal to t squared minus 8t plus 17. All right, now let's find the blue one. We're gonna find actually this, the whole thing. We're gonna find this whole thing. All right. Okay. We know the vertex. Vertex is 8, 9. So vertex is 8, 9. What time it is? This is okay. We have a few minutes. Vertex is 8, 9. The other point is this is 6, 5, and then this is 10, 5. All right. We have 3 points. So we're gonna write it 3 times. Y is equal to ax squared plus bx plus c. Y is equal to ax squared plus bx plus c. Y equal to ax squared plus bx plus c. And x is equal to negative b over 2a. So x is 8 is equal to negative b over 2a. Okay. So b is equal to negative 16a. Okay. So what is our vertex? Our vertex is 8 and 9. So when y is 9, this is 64a, this is 8b. When y is 5, this is 36a, 6b. When y is 5, this is 100a, 10b. All right, so let's see 100a, 10b. Let's do that one. 100a plus 10b plus c is equal to 5. And this one, this one actually we must do the vertex one. 64a plus 8b plus c is equal to 9. All right, so we're gonna do negative, 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 negative. Okay. All right, so this cancel. So 64 70, 36. So this is negative 36a. This is plus 2b. This is minus 4. All right, so b is negative 16a. So this is 36a. This is negative 32a equal to negative 4. So this is let me do this one. 64a 64a plus 8b plus c is equal to 9, and then 36a plus 6b plus c is equal to 5, and we have negative sign, negative sign, negative sign, negative sign cancel, and then 36, 46, 56, 66. This is 28a. This is plus 2b is equal to 4. 28a minus b is how much? 16. So 32. So minus 4a is equal to 4. So a is equal to negative 1. Then b is equal to 16. So a is negative 1, b is 16. All right, let's see c. All right, 5 is equal to a is negative 1, and this is b is 16 plus c. So this is 5 is equal to 60 plus c. So negative 55. C is equal to negative 55. So y is equal to ax squared plus bx plus c. So y is equal to negative x squared plus 16x minus 55. So p of t is equal to negative t squared plus 16t minus 55. So what is this one? P of t is equal to negative t squared plus 16t minus 55. All right, now last one. Last one is linear line, so it's going to be easy to describe. From here to here is linear. So I have 2 point. This is 10, 5, and this is 35 over 3, 0. All right, let's see the slope. y2 minus y1. This is x1, x2, y1, x2, y2. So y2 is 0 minus y1 is 5. So 0 minus 5 is delta y is minus 5. What is delta x? x2 minus x1. x2 is 35 over 3 minus x1 is 10. So 3, 35 over 35 minus 30. So 5 over 3. Delta x is 5 over 3. So delta y over delta x. So negative 5 over 1 and 5 over 3. So that means you have negative 5 over 1 times 3 over 5. So negative 3. Slope is negative 3. So y is equal to mx plus b. Y is equal to negative 3 t. X is, all right, y. Let's see y. Y is 5. 10. All right. So 5 is equal to negative 30 plus b. So negative 35. B is negative 35. So y equal to mx plus b. So y is equal to minus 3x minus 35. Is it minus 35 or plus 35? plus 35. Okay, so y is mx plus b. Y is minus 3x plus 35. So P of t, this one, is equal to negative 3t plus 35. I'm going to move it over there. So quickly I can do, this is A, this is B, this is C, this is D, this is E, this is F, right? From here to here is A, here to here is B, here to here is C, here to here is D, here to here is E, and here to here is F, okay? So now A, B, C, D, E, F, good? I'm gonna first find the displacement. What is the displacement between 0 to 2 seconds? Well, 0 to 2 second displacement is always, don't forget, df minus di, right? So 1 minus 0, this is 1. Displacement between 2 to 4 seconds, 1 minus 1, this is 0. Displacement between 4 to 6 seconds, 5 minus 1. Displacement between 6 to 8 seconds, 9 minus 5. Displacement between 8 to 10 seconds, 5 minus 9. Displacement between 10 to 10.67 seconds, well, of course, 0, minus 5. So what are you noticing over here? You notice very important thing. What? From 0 to 8 seconds, 0 to 8 seconds, 1 plus 0, this is 1 plus 4, which is 5 plus 4, which is 9. This is 9, right? Okay. And from 8 to 11.67 second, what is it? 8 to, you have minus 4 and minus 5. So, also 9. So what do you discover over here? You discover that the distance is this on A plus B plus C plus D plus E plus F. Absolute value, of course. Alright, so the distance is A is 1, B is 0, C is 4, D is 4, E is negative 4, and F is negative 5. So total distance is 18. And total displacement is A plus B plus C plus D plus E plus F, right? So total displacement is 1 plus 0 plus 4 plus 4 minus 4 minus 5. So total displacement is 0. Okay, muted. Good. Now we're going to convert this one to VT graph now. Alright, so we're going to convert this one to VT graph. How are we going to do that? This is how we're going to do that. This is a VT graph, velocity versus time. So when the dt is a diagonal line, VT must be horizontal line, right? VT must be horizontal line, right? Okay. Until 2 seconds. When VT is horizontal line, when dt is horizontal line, when the dt is horizontal line, VT must be 0. When the dt is curved, VT must be a diagonal line. But diagonal line at what direction? Diagonal line at this direction. Why? Is because over here, what happened over here? Velocity and acceleration both are at the same direction. When both are at the same direction, then you are speeding up. When you are speeding up, since velocity is 0 on the x-axis, since you are speeding up, you're moving away from the x-axis. And this is how you know that you are speeding up. This is how you know that you are speeding up. Okay. So why is that? Velocity acceleration in the same direction. Okay. Now from D to E, now D. Okay, D. From here to here. Well, here to here, object is slowing down. How do you know? Because velocity is positive, acceleration is negative. So object is slowing down. How do you know object is slowing down? Because as you remember, when I do the demo, the object is from 6 seconds to 8 seconds. At 6 seconds, the velocity is maximum, which is 4 meters per second. At 8 seconds, the velocity is 0. From 6 seconds to 8 seconds, velocity is 4, velocity is 3, velocity is 2, velocity is 1, velocity is 0. See, velocity is, speed is decreasing, velocity is decreasing. All right. So when velocity is decreasing, what does that mean? It approaches to 0. And this is how it approaches to 0, right? It approaches to 0. And velocity is 0 here at 8 seconds, velocity is 0 here at 8 seconds. Now, section E. Is it speeding up or slowing down? Is speeding up. Why it is speeding up? This is speeding up is because the velocity and acceleration are at the same direction. All right, so it's speeding up, but velocity is still negative, right? Is it speeding up? Why is speeding up? Because they both are at the same direction. Who are at the same direction? The both vectors, and velocity is negative. That means you keep moving this direction. Okay, good. So, all right, good. Good. This is a continuous line. This is a diagonal line. All right. And now here, what do you do? You move with constant velocity, but velocity is negative over here. Okay. So if the dt graph is a diagonal, vt graph must be a horizontal. Okay. So from 0 to 2 seconds. Your velocity is half. Why velocity is half? Okay, so in math class you call it slope, right? So in physics class this is your velocity. Okay, and what is the velocity over here? What is the velocity over here? Velocity over here, okay, look, over here is -3. Velocity is -3. Okay, now we don't know the velocity over here. Okay, we don't know the velocity over here, and we don't know velocity over here. Okay, so we're gonna find this velocity. How are we gonna find it? Okay, we're gonna use the information we already know to find those velocity. So let's first shade area under the graph. Okay, let's take the other one. And finally, this one. Okay, now let's see how much is this one. This one is 1 meter. This one is 1 meter. Displacement is 1 meter. This one is 0. This one is 4. This one is 4. This one is -4. And finally this one is -1. Okay. So we want to know the velocity right here. So to do that, this is a triangle. So what do we know about the triangle? Area is half BH. Area has a name, displacement. B has a name, time, and H has a name, velocity. Displacement is 4. You have this one, you have 6 minus 4, and velocity. So velocity is 4. Okay, very nice. So what is the velocity over here? Okay, we're going to do the same thing. Area is half BH. Why half BH? Because this one is a triangle. Area called displacement. B is delta t and H is velocity. Displacement is -4. This is your 10 minus 8. So velocity is -4. Velocity is -4. Good. So what is the velocity? Velocity here is half. Uh, 0.5. Velocity here is 0. Velocity here is 4. Velocity here is 4. Velocity here is -4. And velocity here is No, that's not the velocity. Velocity here is half, right? Velocity here is half, velocity here is 0. Velocity over here is 4. Okay. Right? And velocity over there is 4, velocity over there is -4, and velocity over there is -3. Alright, good. Now we're gonna find the acceleration. So what is the acceleration here? 0. What is the acceleration here? 0. What is the acceleration here at location C? Well, acceleration is Vf minus Vi delta t. Okay, at Vf, okay, at location C, at Vf, what is the velocity? 4, final velocity. Initial velocity is 0 over 2, right? So 6 minus 4, which is 2. So acceleration is 2. Okay, now acceleration over here. All right, Vf is 0 minus Vi is 4 over 2. How 2 is 8 minus 6. So this is acceleration is -2. Okay, what about acceleration over here? Vf is -4. Vi is 0 and t is 10 minus 8. So it's -2. Acceleration is -2. What is the acceleration over there? Acceleration is 0. Okay, so let's see whether our answer does actually make sense. Earlier, what did we say? We say, oh, before we do that, we have to convert this to AT graph. So, acceleration 0. First 2 second acceleration is 0. Next 2 second acceleration is also 0. Next 2 second acceleration is 2. So this is 2, this is 4, this is 6. Next 4 second acceleration is -2. So this is 10. And next 2 second, next 1.67 second acceleration is 0. Okay, so this is 2, this is -2. Okay, now let's see whether our answer makes sense actually. This is DT graph. So this is A, B, C, D, E, and F. Okay, so what do we say? We say that the velocity is positive over here, and now we know the size of the velocity. Velocity is 0.5. We said velocity is 0 over here. Check. We say the velocity is not only we say velocity is positive over here. Now we know that this is 8 times as big as this one. Velocity is 4. We say velocity is positive over here, which is velocity is still 4. We say velocity is negative over here, and we know that velocity is -4. We say velocity is negative over here, and the velocity is -3. Okay? We say acceleration is 0 over here, and this. We say acceleration is 0 over here, and this is this. We say acceleration is positive over here, and now we know acceleration is 2. We say acceleration is negative over here, now we know acceleration is -2. We say acceleration is negative over here, now we know acceleration is -2. We say acceleration is 0 over here, and this is. So this is how we not only know the direction of the vectors, but also size of the vectors. The size of the vectors is 1.5 because this is a velocity vector. The size of this vector is 4 because this is a velocity vector. The size of this vector is 2 because this is acceleration vector, and so on. Okay, so this is your quiz tomorrow.